Hello and welcome to this video on Rust programming. In this video, we will look at associated functions and methods. This is going to be a very simple video, nothing complex, but it is one of the most important videos in the entire playlist. So watch carefully. So we begin by learning about two things. One is type and another is an instance of the type. So for example, when we say in Rust x is equal to 5, okay, let's put it somewhere where we can get the type. Okay, so for example, to understand it simply, if we say let x is equal to 5, then the Rust analyzer tells us that it is I32. Now I32 is a type. X is an instance of I32. That is, X is a variable and 5 is our value. Okay. So be clear. X and 5 are basically the same thing here, but they are slightly different also. Okay. But I32 is the type here. So I32 is the type and X is an instance of I32 having value 5. So be very clear about these three things. Otherwise, very soon you will fall in trouble. With that out of the way, let's get started on the actual content of the video. Suppose we declare a structure point. By the way, this entire example has come from Rust by example. So this structure point is will denote a point x and y. So x is the x coordinate and y is the y coordinate. It is in Cartesian coordinate. Both are of type F64. So here the structure point defines a type. It is not a value, it is not an instance, it is a type. Now we can have an implementation block. In Rust, there is concept of implementation block. And we can write a function origin which will return a point. So this will construct the point with argument 0 and 0 for x and y. So 0, 0 will be our origin. And it will return the point. Another associated function may take two arguments x and y of type F64 and returns the point constructed by those arguments. Now here both the functions origin and new are called associated functions. These are not methods. So the way to call these will be point colon colon origin and point colon colon new. So for example, you can say point colon colon origin, okay, or you can say new. That's how these functions will be called. If you want to see the full call, this is how it will be called, and origin will be called, new will be called with argument. You can say pass 3.4, 8.7 or something like that. So this is how these two functions will be called. Now consider another type, a rectangle. For the rectangle, we have 2 points, P1 and P2. So once you have 2 points, you can define a rectangle. It can be left, top, right, bottom. 2 points are enough to define a rectangle. So in the implementation block of rectangle, it takes an argument ampersand self. As you can read, this is just a shorthand for self colon ampersand self, where self is the type of the object. Here it will be rectangle. This self is much like this pointer of object-oriented programming like C++ or Java or self of Python. So this means whenever you see ampersand self as an argument to a function, you should think that it is a method of that particular structure. So it will operate on an instance of the structure. Okay. So self, the area, this function area will compute the area of the rectangle and give you the value. So it takes P1 and P2 and destructures it into 2 points. The first point is x1 and another point is x1y1 and x2y2. And it computes x1 minus x2 into y1 minus y2 and finds the absolute value and returns. Similarly, it computes perimeter. So the perimeter computation is similar, nothing complicated there. And then the third function takes a mutable self. So the object which will call the function translate should be a mutable object. So in this case, the self is being modified. Self.p1.x is increased or decreased depending on the value of x, whether it is positive or negative. And similarly, p2 is also increased or decreased by the same amount, and same for p1. Same for y coordinates of p1 and p2. Now the third type which we have is a pair, which is box of I32. Box means it is allocated on heap. Okay. Think of something like, you can say pointer I is equal to int star I is equal to malloc size of int, something like that. Or in Java, you have new operator, or in C++, there is new. So it has a destroy which consumes the self object. Note that here there is no ampersand. That means the object will be moved here. You cannot use that object after destroy is called on the object. So it destructures self into first and second pair, and then this pair will go out of scope and the values will be destroyed. So I hope that this is clear till this point. Now we will see the uses. So first we construct a rectangle from the rectangle type. The P1 is point origin and P2 is created by point colon colon new x3 y4. Okay, this is from Rust analyzer. Okay, x colon 3 y colon 4. Now we call perimeter and area. So you can see the dot perimeter and dot area is applied on the instance of rectangle, or in other words, you can call object. I don't want to call it an object, because the term object is closely related to object-oriented programming, where a class has an object. This is very much like an object, just that I don't want to call it. I want to call it an instance of the structure rectangle. So you invoke perimeter and area, and then we have another rectangle, and we create similarly from origin and xy11. Now this rectangle is mutable here. Sorry, this square is mutable. So it can be translated, because remember, translate requires a mutable object. Note that our first rectangle is immutable. So if we uncomment this, Rust analyzer will give us an error. It will say cannot mutate immutable variable. So one of the easiest way to do is make it mutable, and it can be translated now. Similarly, we have pair. We create two pairs, one pair with two arguments, 1 and 2. This is how to create an object on heap. You call box colon colon new and box colon colon new 2. Remember that in C++ and Java, we have new as the operator which calls the constructor. So keeping in that convention, Rust libraries and methods also implement new to create an object. It is just like following a convention. You can read when you implement something like this rectangle or rather a point, instead of new, you can say something else, create, and it will work nicely. Just by convention, we name it new. So you will encounter this new many times. It is not a keyword. It is not an operator like C++ or Java. Just to have the similarity, we call it new. And then we call destroy on this pair. Okay. Now, once this is destroyed, remember that it was moved. This will throw an error. You see, use of moved value, because remember that it was passed here like this. All right. So we will have to keep it commented. So if you want, you can see a sample run of this program. So we have perimeter as 14. Remember, 3, 4 were passed. So perimeter would be 2 into 3 plus 4. That is 3 plus 4, 7 into 2, 14. And area would be A into B. That is 3 into 4. 3 minus 0 into 4 minus 0, right? So that would be 12. And we had created the box new of 1 and 2. So it says destroying pair 1, 2. So this was all I had to say in this video. And I would recommend that you ensure that you understand everything what I have said in the video. Everything means everything. If you are not clear about any point, post me a comment and I'll try to explain you into detail. Okay, because this is probably going to be the most important video I will make on Rust. Okay, I don't think I'll make another as important video as this one. You cannot mess this video. You have to understand the concepts clearly in this video. So I hope that it was useful for you and you enjoyed this video. Do let me know your comments in the comment box. Make sure to use it. I like to interact with you guys. Thanks a lot for watching. Happy programming.